Welcome back to this video on implementing an interpreter in not in Python, in Rust. Last time we handled function declaration. Now there is still an issue, which is that if we try to define a recursive function like this, let's try to do that, then what will happen is something bad. When we call it, it will say something I didn't expect. Okay, because we have to do like that. Then it will say not yet implemented, didn't get an expression. So it will fail in here. So what is it getting? It's because the last thing is a print statement, which doesn't return a value. So later on in this video, I think we're gonna implement return statements. So for now, I think we can get away with this. And we can get away with removing this and this. Then we need to return a valid value, so I'm going to return nil for now. And let's try to run it. Do the same thing. And we'll call count 3. And now it just prints 1, 2, 3. And if we ask what is the value of this thing, then it's just nil. So that is great. Let's add a test. Where we can just, do exactly that. And actually, it would be nice if we could just write here's the test. Here's expected out. But that is for another video. So actually, yeah, we should for sure do that. So I want to say that, let me write that up. Okay, so here's the test. And I also had to update this to actually call the function. Let's do another one where we actually modify the environment. So I want to say a equals true, and then we'll call it modify. It doesn't take any arguments, and it will just say a equals 3. And then I want to print a, and it should give me 3. So do that. Here's the test. Also, I again forgot to call it, so we need to actually call the modifying function. And we run the test, and it passes. Great. So now I think the time has come to look at implementing. We already have function declarations interpreted. Yeah, return statements. So let's go into statement and add return statement. I guess, and it should have a, let's call it value, which is an optional statement. No, sorry, an optional expression. It doesn't need to be boxed. So there we go. And then we need to add something to the expression. Tree, I think. Variable. No. No, it's just this. And okay, we also add the. We can also add the keyword. Why not? And then we fix up the parser. So we go up here where it looks for. Rather, we go into statement where it looks for the keywords. And then if we find a return keyword, then we need to get a return statement, which we will implement. And we will implement it like this. And value will be equal to something if we don't get a semicolon. So it's like if it's not just not return semicolon, then we will try to get the expression that is equal to, and then we need to consume the semicolon. And finally we can make a return statement with the keyword and the value, and it has to be okay. It did not, because I called it return statement. And this has to be, okay, so otherwise value is none. And here we say it's some expression. Great, now we just get these problems here. So here he's talking about how to implement this. He's gonna use it using exceptions, but let's just try to do it our own way. So if we get a return statement with a keyword and a value, what do we need to do? The thing is, we are interpreting here, right? And then if we see, if we end up seeing a return statement, we want to get the value of that. So we can handle that in a special way, or we can change the return type to be like an option of a value. Which I'm not sure what the implications of doing that is. I don't really like the idea that statements also have values now. Because it's not really the kind of language we're making. But I don't see a better way to do it. We could we could do something very funky, like saying if return is a keyword, so they can never use it as a variable name or anything. So we are kind of free to do this. So first we have this expression that we need to evaluate using the environment, and then we can put that into here, and then we have to see if so. Something like this. So if we encounter a return statement, no, I don't think it's gonna work. But then like we get the value from the environment, and we just return that value. Let's see if it even compiles. It does not compile because this one has to be dereferenced, and we need to say borrow. And then I have to change it back to not return a value. This is kind of an interesting way to do it, because then you could have more reserved keywords than return. I don't know. Maybe it's interesting. What's wrong now? Line 132. Why does it want an option? I don't get it. This is inside the closure. It shouldn't care about that. Okay, so now it's thinking that this... it's because... Expect... okay, so let's say... How is it? Is it like sum or literal value nil? Not sure. Let's try that. So this problem is this guy. It's not doesn't have the right type. So let's annotate it so the compiler will actually tell us what is wrong. And it's not self.environment. It is the closure interpreter's environment that we need to use. Mismatch types. Expected a literal value found result. Okay, another thing we need to remember is that the return statement is an optional. So we will say if let some value equals value, then we do that, else actually let's say evaluated value is this thing. Otherwise it should be nil. And then it's that thing we put in here. Okay, so what is going wrong here? So it's also complaining that this thing needs to be allocated over there. Let's see here if we can get it to work. Okay, so we do that. It needs to be closure. And again, like borrow. Is it the borrow we need to unwrap? Let's try that. No, and get is just an option. I don't get it. Okay, the problem is it's returning it to it's transforming it to a result value, which is like a little bit annoying. So I have to say instead, let's match this huge thing. And if it is some value, then we do that. If it's none, then we do. Actually, I think I'm okay with unwrapping it, because it's kind of like return value was not defined in the environment, even though return statement was interpreted. We are kind of expecting it to be there, so I think it's fair to use expect. Okay, now it's claiming that return statement is not covered. It's inside statement, and I think there was a test using it. Great, now let's just tell it to ignore this. Okay, now let's make a test. Tests, cases, function return. So let's make the standard test. And then we will say print a 2 plus 3. And then we need to go up here and say interpret function return. And what did I call it? Fun return. And it should be 5. Let's see if it works. It actually worked. Let me try something just for fun. Amazing. We'll revisit the code in a little bit because I'm not sure it's the nicest. Let's make another test case that is fun return nil. Which will be no return, and it should take, what should it do? We don't have string interpolation or anything, so we can just say print A, print B, and it will go like that, and then we'll say no return 1, 2. Oh, we call it return nil. And this should be nil. Actually, we also printed 2 things, so we need that. And the first one should be, already forgot, it should be 1. Second one should be 2, and then should be nil. Let's try that. It failed. Left 3. Output 1, 2. Okay. Don't care so much about how many lines there are, so maybe I shouldn't even test on that. Check that, but whatever. Aha. Let me see here, how do we print nil? So that should be literal value. Okay, here it is, to string, nil to string. Interesting. Let me run it. Okay, because I made a mistake. I want to also print the return value. There we go. So now it should be 4. This one should be lowercase. And now it works. Okay. I want to take a look at this because especially this code up here is not super nice. Like here, we interpret the statement and then we check if it was a return statement. So we could like, is there another way to do it? I'm not sure. I mean, we don't want to use something like exceptions to unwind. I really don't like that. How do we check on the type? Just to make it a little bit prettier. Okay. What if we just, can we do this? Will it complain? I didn't like that. Oops, what am I doing now? Went too far back. Okay. Test run, 21 passed. 0 failed, great. I don't know. Maybe it's okay. Let's try to make a test case. Let's leave it like this for now because I cannot think of anything. So we want to make a conditional return test. So conditional return will say if a is less than 0, then we return 0, just something like this. Otherwise, we will say like return a plus 1. A minus 1. And then we want to try that a couple of times, printing the value all the while. So let's print the numbers like 3, 2, 1. And then like 0, 3, 2, 1, 0. And now zoom out again. Oops. What did I just do? Okay, conditional return. So we expect 5 lines of output probably. 3, 2, 1, 0. It failed. Left equals, yeah. So actually it's not, enough to do this, because what we just saw that was that if we have a an if statement, right? Then at this level, it's an if statement. So actually, we have to do something like borrow, get, return, and then if there is a value, inside that, then we return the value. And then this can go away. Let's see if that runs. Okay, so now it works. Even with like return statements inside other statements. But this, I hope that this fails, otherwise this whole scheme won't work. Expected variable name, so that's great. And can we do like print return, expected expression? Okay, that's great. So all of that works correctly, and we are kind of secretly using the environment to define this return thing. And this is only okay because we know that the user will never be able to do this themselves. Right, because return is a reserved keyword, they cannot define a variable with that name. But it is a little bit, I'm not sure if it's a great solution. Let's make a little bit more nesting. Fun, very nested. So this one can say like, if a is greater than 3, then if a is greater than, or let's say, yeah, something like this, then we just want to return a. Otherwise, we can make a block and say a equals a plus 2, return a, and we can also, just for good measure, add a return statement here, which it should never hit. So if we say nested 2 and print that, it should give 2. If we print nested 1, sorry, this is the wrong way around. If we give nested 1, it should return 3. So this should give 2, 3, and never -1. Okay. Three lines, and it should be 2 and 3. And it failed. Left is -1, and this one is 2. Uh-oh. Wait a second. So it's ignoring both of those return statements that we have inside blocks, which is not great. Can I say Kakote for nested? What will it do then? Nothing. Because it's... So. Okay, then we only run that, which is exactly what I want, because now I'm going to... panic in here. Or rather, I'm going to print something. And we're going to see what happens. So I want to run this one. And I want to not capture the output. So it does. Right, we call it once, it interprets both of them. Which is wrong. It definitely shouldn't interpret both. Because as soon as it hits one, it should. Well, it's doing 2. Why is it doing 2? So let's say that we also print the value. Can we do that? Let me try that one just for fun. Or rather, let me do this. So in the first call, what happens? We go here, we interpret that, then we interpret this one, and then finally we interpret that. And it's because these return statements are not defined in this environment. They're defined in an environment further in. So actually, I think we need the globals. We need the globals. Let me try to set it up off screen. Actually, I'm gonna try something else. I'm gonna make a function here that is called define top level. Which should have the same effect. So we need to say match enclosing. If there is no enclosing, then I can define it in my own environment, because then I should be top level. Otherwise, I should say environment, borrow mutable, define top level, name value. And these need to be commas. And then when we go in here and we say, we define the return value to be something, we just define it on the top level instead. Now let's try to run the test. It failed. Now both values are 2, which is very interesting. Yes, because if we find a return value, we also need to delete that value. So it's not like polluting the environment for the next function call. I think. Actually, what happens if we let me get rid of that. So I'm worried that the environments are getting mixed. So I want to check that it's actually creating two, like an environment for each separate function call. So we should see this message twice when we run the test. And we do see it twice, so that's good. It's here and it's actually it's a little bit weird the way it's for nested creating. Yeah, so but why isn't it actually printing it? It's because we're already capturing it, whatever. Okay, so creating a new environment for closure. And I actually just want to make it look slightly nicer. So that was actually the wrong place. Okay, output is creating a new environment for closure, and then it goes in here. Okay, so here's the problem. The closure environment gets the parent environment. So when we say define top level, it goes to the very, very top level. So either we need to really delete it, or what I think is better is to make sure that the return value can never escape the closure environment. So perhaps we need We could use a separate type, but I don't want to do that. We could make it so that when you try to get the return value, it will automatically delete it if it's there. Or we could make it so that the interpreter doesn't, like, has its own. Yeah, so I think that's what we are gonna do after all. We are going to make something we call globals, and then we're just gonna chuck that in here. So the closure will have it, maybe it should be called something other than globals, but whatever. So for now it's called globals, and then when you make the return statement, it will look at the globals and define that. And this one will not look in the environment, it will look in the globals to see if there's a return value. And then because the globals, they like are created anew every time you make a closure environment, there will be no cross pollution like what's happening now. So let's run this test, and because of all this debug output, it's failing, but it is actually printing the correct things. So let's remove the print here. That one should be there, so let's not remove that. This one should not be here, and let's try again. And also that one up here in the foreclosure. Okay, now it passed. So it's quite important to make sure that the closure environment, at least the way we're using it, doesn't pollute the other environments. At least when we're using it for return values. And probably it shouldn't be called globals, right? It should be called like specials. Like right now we are only putting one value, so even it could even be like return value, specific field for that. But I like this, it kind of suggests that we could put more things in here. It kind of suggests that this global should be called something else. It should also be called env, and env globals, and this should be not in globals, it should be in specials. This one we can delete. Specials. Okay. Let's run that. Still works. And I think that's it for this video, because we've been going for quite a while. Close other tabs. But now we have return values that work correctly. They return from where they should return. We are not using exceptions. And default return value is always nil. You can say return semicolon, it will return nil, or you can not have a return statement and it will also return nil. And that is it, I think. So let's leave it at that for now. See you in the next video.